Hi there, Sir Amboy here, and welcome to another episode of my lecture series in differential equations. In this episode, I will start my discussion on Module 2, which is all about first-order differential equations. But before we start solving problems, let us first take a look on how these differential equations are expressed and how they are written. Okay, so let's begin. A first-order differential equation of first degree may be written in various forms. First, here we have the differential of x multiplied by a certain function of x and y, and here we have the differential of y dy, which is also multiplied by another function of x and y, and it is equated to 0. So here we have differentials dx and dy, and because we don't have derivatives and instead we have differentials, we call this the differential form. Now, aside from the differential form, we have the derivative form. In the derivative form, we have the first derivative, y prime, or possibly that could be written as dx or dy over dx is equal to a certain function, possibly a function of x and y. So once again, we call this the derivative form. And in the derivative form, the first derivative is on the left and all the other terms are on the right. Now, the third form that a first-order differential equation may take is what we call the standard form. In the standard form, all functions of the dependent variable, including its derivative, are all written on the left side. And on the right-hand side, we have a function that is purely in terms of the independent variable. So here, the independent variable is x. That's why on the right-hand side, we have f of x. But in case the independent variable is t, for example, then on the right-hand side, we will only have terms containing t. And again, on the left side, we will have all the terms containing the dependent variable, which in this case is y, and all of its derivatives. So again, that's what we call the standard form. So these are the three ways of writing or expressing a first-order differential equation. Now, what are the different types of first-order equations? A first-order differential equation may be classified in various types, and I'll be giving you some popular types which we will be discussing one by one. First, we have the separable equations. Next, we have also the homogeneous differential equations. When we say homogeneous here, we are referring to coefficients, homogeneous coefficients. So I will discuss more about homogeneous equations in the next video. So aside from homogeneous, we also have exact differential equations. And if there's an exact, there is also what we call the non-exact differential equations. And also, we have the linear differential equations. We will have a lot of discussions about linear differential equations when we reach Module 3 and Module 4. And finally, we will have Bernoulli's equation or the Bernoulli differential equation. So in this episode, we will focus more on separable differential equations, and I will devote another episode for each and every one of these types. Okay, so now let us discuss the first type of first-order equation called separable differential equations. Consider the differential equation m of xy dx plus n of xy dy. So if you remember, this is what we call the differential form, or possibly we have the derivative form dy over dx equals a certain function of x and y. If we are able to write this differential equation in such a way that all the x's will be separated from all the y's, then the differential equation is said to be separable. So if this dx has a multiplier which is a function of only x, and dy has a multiplier n which is now function of only y, then this differential equation is said to be separable. Now, if we are able to separate the variables, the next step is to integrate both sides of the equation to obtain the general solution. So now, let us integrate. First, we have the integral of the term m of x dx plus the integral of the term n of y dy, and when we integrate 0, we will get an arbitrary constant c. Okay, so this is now our general solution. So now to illustrate to you how to solve separable differential equations, let us solve the first example. Solve the differential equation 9y y prime plus 4x equals 0 and express your final answer as an explicit function of x. So, the instruction is clear. Our final answer should be expressed in this form: y is equal to f of x. Y should be expressed explicitly as a function of x. So, what's the first step in solving this differential equation? The first step is to express y prime in terms of dy over dx. So, 9y multiplied by dy over dx and then plus 4x equals 0. So here, in order to separate the variables x and y, we need to multiply both sides of the equation by dx. So here, again, we need to multiply both sides of the equation by dx so we can eliminate the presence of x on the left-hand side, or on the first term rather. And this 4x would now have a multiplier of dx. So let us rewrite the problem after multiplying this entire equation by dx. So we will have 9y dy plus 4x dx equals 0. So since the variables are now separated, we can now proceed to integration. And integrating both sides, we will get 9y squared over 2 plus 4x squared over 2 equals c. Now, to simplify our answer, we multiply both sides of the equation, this time to eliminate the denominator. So it would be best if the final answer is expressed as a single line. So there will be no fractions. So that's the simpler way of expressing your final answer. So we will get 9y squared plus 4x squared equals c. So now finally, this is our general solution. So we have 9y squared plus 4x squared equals a certain arbitrary constant c. Now, you may recall that the general solution of a differential equation represents a family of curves. Now, you may ask, what family of curves does the graph of this general solution represent? So, by inspecting the general solution here, we see that both x and y are squared. If both x and y are squared, there are three possibilities. It could be a circle, it could be an ellipse, or it could be a hyperbola. But if the signs are the same, so both are positive, we will only be left with two possibilities. It's either a circle or an ellipse. So which of the two would be represented by this general solution? Okay, the answer lies on the coefficients of x squared and y squared. If their coefficients are the same, then it's a family of circles. But if their coefficients are not the same, then the graph would be an ellipse. So therefore, since the coefficients of x squared and y squared are not the same, this general solution would represent a family of ellipses. And some members of the family are included in this graph. Now, sir, how do we know whether the ellipse is having a horizontal major axis or a vertical major axis. So in this case, the major axis of our ellipse, which is from here to there, that's the major axis, it's horizontal. So how do we know that the major axis is horizontal? By simply looking at the general solution. Okay, so you just look at the term containing the smaller or the lower coefficient. Since the coefficient of x squared is 4, which is lower compared to 9, then the major axis is along the x-axis. Okay? So kung i-explain ko ito in Tagalog, titingnan mo lang kung alin sa dalawa ang mas maliit. No, kung alin yung mas maliit, then ano yung multiplier niya? X. So that means that the major axis is along the x-axis. Kaya yan ay horizontal. And because here, we do not have any terms containing x only or y only. We only have x squared and y squared. We are sure that the center of the ellipses are all on the origin. Just like what we have here in our illustration. Okay? But before we go on solving more separable differential equations, let us first have a review of conic sections. So when we say conic sections, these are derived from a right circular cone, and conic sections include circles. They also include parabolas. What else? Conic sections also include ellipses and hyperbolas. Okay, so the general equation of a conic section is given by ax squared plus cy squared plus bx plus ey plus f equals 0. So once again, this is the general equation of a conic section. So if we are given the general equation, how do we know if that equation represents a circle, a parabola, an ellipse, or a hyperbola? Okay, so we can tell that simply by inspection. First, if a equals 0, or possibly if c is equal to 0, this means that if a is 0, then we only have y squared. Or if c equals 0, then we only have the term x squared. So, in other words, kapag isa lang ang nakasquare, it's either x squared or y squared. So we have a parabola. The conic section is a parabola. So, if we have x squared, then the parabola is opening either upward or downward. That means we have a parabola having vertical axis. If y is squared in a parabola, the axis is horizontal. So once again, x squared, we have vertical axis. And if y is squared, we will have horizontal axis. Next, how do we know if the conic section is an ellipse or a circle or a hyperbola? So now let us take a look at the signs of x squared and y squared. If a is equal to c, so the coefficients of x squared and y squared, a and c, if they are equal and also they have the same sign, then the conic section is a circle. So usually in a circle, the coefficients of x squared and y squared are both 1. So the equation will be written like x squared plus y squared plus 4x minus 8y plus 24, for example, equals 0. So usually, the coefficients of x squared and y squared in a circle are made 1. Usually, but not always. Next, what if a or the coefficient of a and c are no longer equal and also they have the same sign? So we will have an ellipse. So once again, if the coefficients of x squared and y squared, so that means a and c, are not equal, but they have the same sign, the conic section is an ellipse. And lastly, if the signs of a and c are different. So meaning, if this is positive and this is negative, or vice versa, if this is negative and this term is positive, then we will have a hyperbola. Okay? So I hope that's clear, that if you are given the equation of a conic section, you can simply tell by inspection what the family of curves is being represented. Now, let us proceed to the next example. Example 2, rolling. Ayan, umikot na ang ruleta. Charot, isa pa. Ganda eh. Okay, so let us solve the equation y prime minus x equals 0. And after solving the problem, describe the graph of its solution. So what's the first step in solving the problem? So we can rewrite this differential equation, y multiplied by dy over dx minus x equals 0. So, as you progress and improve your problem-solving skills, sometimes there will be no need for you to rewrite the equation like this. Because if you see that the differential equation given looks like this, you can just multiply both sides of the equation by dx, and of course, mental calculation would be very helpful. Kapag minultiply mo ito ng dx, dito matira lang ay dy, at ito magkakaroon ng multiplier na dx. So magiging ganito lang siya. Y dy minus x dx equals 0. Okay, so we can skip this step because again, as you solve more problems, your problem-solving skill improves until such time that there is no need for you to write some steps. Okay, you can go directly from here to there. And since the variables are now separated, we can now integrate. Integrating both sides, we will get y squared over 2 minus x squared over 2 equals c. So now again, I multiply both sides of the equation by 2 to eliminate the denominator. And so we can express our final answer in a simpler form. So multiplying both sides by 2, we will get y squared minus x squared equals c. This is now the general solution to our differential equation. Okay? The general solution. Now, can we describe the family of curves represented by this general solution? So here, we have a conic section because we have x squared and y squared. And, oops! Shit! Magkaiba ang sign ng x squared at ng y squared. Anong conic section ang nire-represent nito? Magkaiba ang sign. Yes, you're right. Tama ang naiisip mo. This general solution represents a family of hyperbolas. So, since positive ang y squared, alin yung graph ng positive ang y squared? Ito yon, hyperbolas having a vertical transverse axis. So this is the transverse axis. Here, the center of the hyperbola is at the origin. Because just like in ellipses, we don't have any terms containing x or y. It's purely x squared and y squared. So with that, we are sure that the center of the hyperbola is at the origin. Now, it could have a vertical or a horizontal transverse axis depending on which is positive. If this is positive, then the transverse axis is vertical. For example, let me consider this green hyperbola. This is its transverse axis. So from vertex to vertex. So we have a vertical transverse axis. Okay? But if this is positive, that's the answer. But if this constant becomes negative, the graph would have a horizontal transverse axis. That's why, aside from hyperbolas, having vertical axis. Ito yung mga hyperbola na iyan. Ito yung mga yon. We also have these hyperbolas on the left and on the right. So they have a horizontal transverse axis, and that will happen if this arbitrary constant c becomes negative. Now, aside from this, we also have parabolas whose equation is defined by this. X, y is equal to a certain constant k. So, if you see this equation, the graph of this function represents a family of hyperbolas. We call them equilateral hyperbolas. So these hyperbolas, for example here, we have the x and the y axis. They would have a graph that looks like this. So the asymptotes are the coordinate axis, the y-axis and the x-axis. If your constant here is positive. But if the constant becomes negative, the graph will be in quadrant 2. Lagay natin. For example, nag-negative yung k. So, ganito yung magiging itsura ng graph natin. Of course, these hyperbolas will never touch the y-axis and the x-axis because sila yung asymptotes natin. Siyempre, pangit yung drawing ko, no? Pangit. Parang ikaw. Ay! Charot. Sige, let's solve the next example. Solve the equation y prime equals x times y minus 1. So I can write the equation in which the variables are already separated. So here, we will have dy, and this y minus 1 will be the denominator of dy. So that's dy over y minus 1 equals this x would have a multiplier dx. And the next step is to integrate. So to integrate this function, I can use substitution method and let this be equal to u. If I do that, then I can express dy as du, and this will be du over u, which when we integrate is ln of u. So ln of u, which is y minus 1 equals, integrating this, we will get x squared over 2 and then plus c. But again, as much as possible, we would like to express our answer as an explicit function of x, y as a function of x. So to do that, we will raise both sides of the equations or the equation to e, y minus 1. And on the right hand side, we will get e to the x squared over 2 and then plus c. So I can transpose this one there on the other side so that y will be left alone on the left side. So we'll get y equals 1 and then plus, I can use the properties of exponents to write this as e to the x squared over 2 times e raised to c. And furthermore, I can simplify this by writing e raised to c as a single arbitrary constant, for example, capital letter C, for a change, kasi small letter ito eh, no? So, e raised to an arbitrary constant would still have an arbitrary value. That is why our solution is y equals 1 plus c e raised to x squared over 2. So, this is our general solution, expressed explicitly as a function of x. So if there are initial conditions given, we can solve for c and obtain a particular solution. But since no initial conditions are given, then hanggang dito na lang ang ating solution. Hanggang general solution na lang ang ating makukuha. O di ba? Madali lang. Next example. Example number 4. Solve the equation y prime equals 2x times the quantity 1 minus 1 squared. So again, there is no need to write dy over dx. I just multiplied both sides by dx, and this y minus 1 squared would be the denominator of dy on the left side. So our equation can be rewritten this way: dy over y minus 1 squared, and then that's equal to 2x because we multiply both sides by dx, 2x dx. And now we can integrate. Integrating this, I can let this y minus 1 be equal to u. So we will use substitution method. Now, if I differentiate both sides, or if I get the differential of both sides, du will be equal to dy. And I can express this as dy can be replaced by du, and this will be u squared, right? Equals 2x dx. Now, du over u squared can be expressed as u raised to negative 2. So we can now integrating this u to the negative 2 using the integral of a power function that will become u to the negative 1 over negative 1 equals 2x squared over 2 and then plus c. Now, using back substitution, we will have negative 1 over u, which is y minus 1 equals, so these two will cancel, and we will get x squared plus c. Okay, so I can multiply both sides by negative 1 and get 1 over y minus 1 equals negative x squared. If I multiply an arbitrary constant by negative 1, that is still arbitrary, and by convention, arbitrary constants have a positive sign. Now we can multiply both sides of the equation by y minus 1 and divide by negative x squared plus c. So we will get y minus 1 equals 1 over c minus x squared. And finally, solve for y. Okay, itong 1 na ito, ilipat mo doon. So, magiging 1 plus 1 over c minus x squared. Okay? So, since this is now expressed explicitly as a function of x, this is now our general solution. Okay? That's it. Next example, number 5. Solve the initial value problem, y prime equals ay minus b, given that y of 0 is equal to 0. So here, a and b are constants. Let's include that in the problem. A and b are constants, but not arbitrary, because the arbitrary constant is in the general solution. So I can express this in terms of dy over dx. And then that's equal to ay minus b. What will happen if I multiply both sides of the equation by dx? If you multiply both sides of the equation by dx, dx here will cancel, and on the left side, we will be left with dy alone. And here, we will get the quantity ay minus b multiplied by dx. So, here, x and y are together. But, we need to separate them. So, is this equation separable? Yes. Kasi example siya ng separable eh. So, this must be separable. Okay, so what are you going to do? Perhaps you can do some algebraic manipulations first before you multiply both sides by dx. So, what are you going to do? Perhaps you can factor out a here. I will tell you later why. So, dy over dx equals a. So, I make a as a common factor so that I will have here y minus, since here we only have b, this should be b minus a, so that when I multiply a and negative b minus a, what I will get is just negative b. Now, why did we do that? So that we can separate variables. Now, we can multiply both sides of the equation by dx, and divide both sides of the equation by this term, y minus b over a. So again, we multiply both sides of the equation by dx to eliminate dx here, and to eliminate y minus b over a here, we divide both sides of the equation by y minus b over a. Now, let us rewrite dy over this term, y minus b over a would be equal to a times dx. So the variables are now separated. We have all the y's on the left and the x term on the right. So we can now integrate. Integrating this, it will give us a ln. ln of y minus b over a equals ax plus the arbitrary constant. So again, we would like to express our answer as an explicit function of x. That is why I will solve for y. And to do that, I need to raise both sides of the equation to e. So I will get y minus b over a equals e raised to ax plus c. Now, I can solve for y. Y equals, so here, we can again apply the laws of exponent and express e raised to ax plus c as c e to the ax, and then plus this term there, plus b over a. So now, we have our general solution. But we must not stop here because we are given an initial value problem. And remember, if you are given an initial value problem, the final answer would be a particular solution. So we need to determine the particular solution to this differential equation because we have some initial conditions. So remember, this is our general solution and this is our initial condition. Let's continue the solution in the next slide. So let me rewrite the general solution. Y equals c e raised to ax plus b over a with the initial condition y of 0 equals yo, which means that when x equals 0, y equals yo. So I can now substitute these conditions here so I can get the value of c. Let this y be equal to yo. I just copy c. E raised to a multiplied by x, which is 0, plus b over a. But e raised to 0 is just 1. So this will simply be equal to 1, and therefore, we can now solve for the value of c. And obviously, from this equation, the value of c is yo minus this term b over a. So that's it. We are now able to obtain the expression for the arbitrary constant. And we can use this in place of this c to obtain the particular solution. So, let me rewrite y this time without c. And I replace this c with yo minus b over a. And then copy this e to the ax plus b over a. So this is now the particular solution that satisfies the given differential equation as well as the given initial condition. So I highly suggest that you memorize this. If ever, again, you would see a differential equation in this form, then there is no need to solve for its general solution because this is the general solution. Once again, c e raised to ax plus b over a. And if you are given some condition, the value of c is simply equal to, copy-paste ko lang yon, that's yo minus b over a. Okay? So that the next time, if ever, you will encounter this, which is a very common differential equation in this course, there is no need for you to solve manually. Okay? You just memorize this, and if you see this, the solution looks like this. Okay? Now, let us solve some more examples. Example number 6. Solve the equation 1 plus x squared y prime plus xy equals 0. So here, this y prime can be multiplied by dx to eliminate the denominator. And then after that, this can be the denominator of dy. And this 1 plus x squared can be the denominator of x. Diba? Madali lang. So, magiging dy over, ito, yung y mo doon, plus this x divided by the term containing x also, 1 plus x squared equals 0. That's it. Madali silang paghiwalayin, no? Why? Because they don't trust each other. If two people do not really trust each other, madali silang paghiwalayin. Charot. So we can now integrate. Integrating this term, we'll get ln of y and then plus, okay, I forgot to include here dx. Sorry. So if I integrate this, to integrate this, I use the substitution method. If I let u be equal to 1 plus x squared, my du will be 2x dx. And here we have 2x dx. So this can be written as 1/2 of du over u. Okay? And that is what we're going to integrate. Equals, the integral of 0 is just c. So integrating this term, ln of y plus 1/2 times ln of u, which is 1 plus x squared, equals c. Since both terms here involve ln, we can also make the arbitrary constant or express it in terms of ln. So we have ln of y plus, applying the laws of exponent, this could be an exponent of this entire term, 1 plus x squared. ln of 1 plus x squared raised to 1/2 equals ln of c. Sir, bakit? Kasi nga may ln ka dito, may ln ka dito. Aba, baka mainggit yan. Kaya kinakailangan, gawin mo lang din siyang ln of c. Kasi kinakailangan nating masimplify eh. So kung lahat sila may ln, since ito arbitrary, pwede mong kuhanan din yan ng ln of c. Because ln of c is still arbitrary. Now, furthermore, we can apply the properties of ln. The sum of two ln's can be expressed as a product of ln. Recall that ln of x plus ln of y is ln of xy. So we apply that here. We will get ln of y times 1 plus x squared raised to 1/2 and then equals ln of c. So we can now eliminate ln by raising both sides of the equation to e. Y times 1 plus x squared raised to 1/2 equals c. So finally, we can now solve for y explicitly as a function of x by dividing both sides of the equation by this term. So we'll have c, the arbitrary constant, divided by 1 plus x squared raised to 1/2. So here we have an exponent 1/2. So actually you can write that in terms of the square root of 1 plus x squared. So this is now our general solution. Okay? Diba madali lang? Next example, number 7. Solve the initial value problem x y squared dx minus x squared y squared dy equals 0, given that y of 10 equals 0. So the final answer should be a particular solution. Now, if there is a way to simplify the problem first before integrating. If there is a common factor which we can cancel, then divide both sides of the equation by the common factor. Like here, x is a common factor and y squared is a common factor. So we divide the entire equation by x, y squared. So what will be left here is just dx minus x times dy and then equals 0. So I can divide both sides by x, dx over x minus dy equals 0. And finally, I can now integrate. Integrating, I'll get ln of x minus y equals 0. No, not 0, but rather c, the arbitrary constant. So I can now solve for y. Y equals ln x minus or plus c na rin kasi nga arbitrary constant naman siya. Now, since we are given an initial condition here that x is 10 and then y equals 0, then let this y be equal to 0 and let x be equal to 10. So obviously here, the value of c is negative ln of 10. So now, the particular solution of the given differential equation can be written as y equals ln of x minus or plus this minus ln of 10. So these terms contain ln and applying the properties of ln. Ano ang property iyon? Ln of x minus ln of y can be written as ln of x over y. So I can simplify my answer, ln of x over 10. So this is now my particular solution that is free of any arbitrary constant. Now let us solve example number 8. Solve the equation xy cubed dx plus the quantity y plus 1 times e raised to negative x dy equals 0. So let us inspect the given differential equation. Can we separate x and y here? Yes. I divide both sides of the equation by y cubed. And I divide both sides of the equation by e raised to negative x. X dx. So this term here, e to the negative x, will be the denominator of the term containing dx. E raised to negative x. And then plus. So here, y plus 1 dy would have a denominator y cubed and then 0. So since we are now able to separate the x's from the y's, it's now time to integrate. Oh, by the way, I can write this as e raised to x or x e raised to x dx plus this can be written as 1 or simply y to the negative 2. And then 1 over y cubed, that's y to the negative 3. dy equals 0. The next step is to integrate. Okay, so notice here that we will be integrating x times e raised to x dx. If this looks familiar to you, perhaps you were able to solve this problem in your integral calculus. As an example, this would require integration by parts. So recall that the integral of x e raised to x dx equals e to the x times x minus 1 plus c. So that we don't have to do integration by parts anymore. Kasi napagdaanan nyo na yung integral calculus eh. So integrating both sides, we will get here e to the x times, I'll just copy this, x minus 1, or if you want, that could be as an exercise for you to review your integration skills. Plus, if I integrate this y to the negative 2, the answer will be y to the negative 1 over negative 1, and then plus y to the negative 2 over negative 2 equals c. Now, let us simplify this by writing these terms involving y on the right-hand side. Okay? So we will get e raised to x times x minus 1 equals this term transposed to the other side will be positive 1 over y, and this term transposed to the other side will also become positive, so plus 1 over 2y squared and then plus c. Okay, so this could be our final answer. So here, it's not that easy to express y as a function of x. That's why it's okay if your final answer would be in this form. Let us now solve the last and final example for this episode. Example number 9. Solve the equation y prime equals 2x times 1 plus y squared times e raised to x squared. So by inspection, we have here the derivative term on the left side. So if I multiply both sides by dx, this would have a multiplier dx. The left side will be left with dy alone. And because of that, I can make this 1 plus y squared, the denominator of that, dy. So dy over 1 plus y squared equals 2x e raised to x squared multiplied by dx. So now the variables are already separated. We can now proceed to integration. If you are familiar with this term, integrating this will give us the inverse tangent of y. And integrating this term, we can let u be equal to x squared and du is 2x dx. So using the substitution method, I can express this entire right-hand side as e raised to u multiplied by 2x dx, which is du. So that's e raised to u du. Na-i-integrate natin. Okay? Tangent inverse of y equals e raised to u also. But u equals x squared. And then we add the arbitrary constant plus c. So can we express this explicitly in terms of x? In the form y equals f of x? Yes. So if we get the tangent of both sides, the tangent will cancel the inverse tangent, leaving us with y alone on the left side. And on the right side, we'll have tangent of e raised to x squared plus c. Okay? So this now represents the general solution of this differential equation. So that's it. Okay? So we are done with separable differential equations. Na nakita naman ninyo, madali lang gawin, no? Paghiwalayin mo lang ang x at y, pag napaghiwalay, i-integrate, pag na-i-integrate, simplify, no? Sulat natin yung summary ha. Separate variables by some algebraic manipulation. The next step is to integrate both sides and then simplify the final answer. That's it. Ganun lang po kasimple. So in the next video, I will discuss the homogeneous differential equations. So see you in the next video. Bye!